Hello everyone, in the previous video we discussed in detail how to solve the question interval list intersections. In this video we'll be implementing it, and in the video we discussed the four questions that we need to answer in order to solve this question. I've written them out here and we will take them one by one and solve our question in this manner. So question number one, how do we start the process? We'll start the process by initializing our answer variable. Let's call it the result, which will be an array. I will initialize the two pointers, which will point to the first elements of both the lists right now, which is at index 0 naturally. Alright. Then I will start my iterative process. So I say while, and this is what we discussed at the very end of the last video, while there are elements left to process in either of the lists, we continue this process, otherwise we end it, which can be written down as while the first pointer is has not gone through all the elements of the first list, and the second pointer has also not gone through all elements of the second list, we continue our process. So the question that we had with us was, how do we find the intersection between the intervals to wherever the pointer is pointing at? So I say that first let's get the elements at the pointers. So current first list element would be at the pointer variable, pointer index of this list. Same goes for the second one. So I'll double R. Of course, we'll go with the pointer number 2, or pointer number 2 for the second list. Now, these are the elements that have our intervals that we have to test right now. How do we find the intersection between them? We find out the intersection in this manner. We take out the maximum of the starting points, that will be the starting point of the interval, and the end point of the interval would be whatever the minimum of the two ending points is. So let's say var low and var high. All right. So the lower point in this range would be the maximum of the two starting points. The starting points would be found at the 0th index of both the lists. So we get that like this, and for the second list we do the same. And to get the high, we get the minimum of the two ending points, and the ending point would be found at the first index. So that is how you get the intersection. Now the next question that we were supposed to answer is how to handle the non-intersecting intervals. So I say that, okay, before we get there, actually, let's just, make up our answer while we go with it. So we found the intersection, we have the start point, we have the end point, and we will push it to our result variable before moving on to the next question. So we have the push function to help us with it. Now the next question, how to handle the non-intersecting intervals. So I say that, let's handle the non-intersecting intervals before we try to find the intersection. Because if we don't have an intersection, let's not bother with this entire process. It doesn't make sense for us, right? So let's skip that thing entire together and handle it beforehand. We'll do that over here. So we have two cases. That the first of which would be that the interval in the first list comes before the interval in the second list. So in, let's say, list 1's interval ends before list 2's interval, right? And then the other case is list 2's interval ends before list 1's interval. And we have to test out both of these cases. If we look here as an example, if we are comparing this interval in list 1 with this interval over at list 2, what we have to test is if the end point of this interval comes before the start point of this particular interval, then there is no intersection. We move forward. So if the end point of the first list, which is at index 1, comes before the start point of the second list, we move forward. Where do we move forward? We move forward from the trailing point. The trailing point in this, the trailing interval would in this case would be at list 1. So we move the pointer forward from list 1, right? Because its end point comes before the start point. So we need to move it in such a manner that there is a chance of an intersection. So we move the first pointer forward, and that's just what we've discussed in the previous video, nothing new. Otherwise, we test if the same thing happens but in inverse order. So we'll change the variables up a little. So the end point of the second list element, if it comes before the start point of the element in the first list, we will move the pointer at the second list forward in a very similar fashion. So that's basically how you handle the cases where we are not supposed to have any intersections at all. And of course, if we don't have any intersections, we don't need to do all this. So what we can simply do is continue. Because we don't need to process this part. We can simply move on and try the next combination out. So we've handled intersections, we've handled a case where intersections don't occur. Now, next question is, how do we actually move the pointers forward? Now, the question is, which pointer is to be moved forward? We discussed previously that we move the pointer that is trailing, the one that is behind. For example, if we are looking at these two pointers, this is interval 1 and interval 2 over here, we move the pointer that ends first, right? So we move this one over to the next one and then we try these two out. That is basically what we're supposed to do. So if the endpoint of the first list comes before the endpoint of the second list, we move the first pointer forward. Otherwise, we move the second pointer forward. And at the end of it all, we will return our result. So let's try to run this and see if we have any syntax errors by any chance. Okay, it has been accepted. Let's try to submit this. And it's accepted and we have a pretty good result. And that's how you solve the question interval list intersections. And if you like this one, subscribe for more and I'll see you in the next one.